because we're in the middle of a terrific revolution in biology that nobody knows. Well, only a few scientists are aware of. Everybody knows Kim Kardashian and everybody knows Meghan and Harry, and they can tell you everything about their lives. But in the background, this magnificent explosion of scientific knowledge is occurring. And it's going to dramatically change your life and your life, if you're middle-aged and above, it's going to very substantially change the lives of your children and grandchildren.
Welcome to Zestful Aging, where I speak with fascinating changemakers from all over the world who will inspire you to live with zest. I'm your host, Nicole Christina, the psychotherapist and fellow Zestful Ager, and my new tagline is Discovering Your Sweet Spot, both because I love a good tennis reference and because this show is all about growing into ourselves as we age. To find out more about the podcast, hop on over to zestfulaging.com. While you're there, sign up for my weekly email newsletter, The Insider, where you will get behind-the-scenes looks at our guests and other fun and quirky tidbits. And if you love the podcast, I'd be grateful if you shared it with your friends. Our music is courtesy of Judy Banker, who was a previous guest on the show. Find out more about Judy Banker at her website, judybanker.com. She's been very busy with her music lately. Our technical director, as always, is Stephen Litweiler. Well, we have been talking about cellular health lately, and we've been hearing about the importance of keeping our gut microbes healthy. But what if understanding our cells helped us understand our whole selves better? After a career practicing medicine, our guest became fascinated by evolution when he saw Sue, a T-Rex skeleton housed in the Chicago Field Museum. And since then, he's become a leading expert in the field of evolutionary biology. Today, we're speaking with Dr. William Miller, who is an internationally known evolutionary biologist and medical doctor. And we're going to talk today about how the cellular world contains the secrets to life's biggest questions. Welcome to the show.
Well, thank you very much. It's a treat.
Well, thank you. I have already shared your book with a friend of mine who's a biologist, so I was hoping I might be able to have a conversation with him about this. Let's just start with this whole concept that I think really is the foundation of your work, in that our cells are intelligent. And I'm wondering what you mean by that.
Our cells are intelligent because they have very high levels of competency. We didn't know that up until just a very long time ago. If you explore what scientists and biologists have thought about actually all animals, if you think of the Victorian era, for example, there was no organism that was considered intelligent at all beyond humans. And not every human was considered intelligent either. So I only emphasize this kind of Victorian framework because it's a very good idea of how far we've come in the interval. The difference is at each decade, as better scientific tools were developed, we learned that all primates are intelligent. We learned that many kinds of dolphins, whales, so they all demonstrate very interesting forms of intelligence. That's carried forward now to insects. Bees are very, very intelligent. We understand that about, everyone that has a dog understands that dogs have inner lives, they have emotions, and they're problem solving. They're intelligent in their way.
There was a very popular Netflix show about octopus.
Oh, what a terrific show that was. And boy, does it make my point. An octopus is an extremely brilliant problem solver in its domains. We would be incredibly unintelligent if we had to inhabit its world. I mean, if we could, we had the physiological equipment. It's it's a transformative view of intelligence. And now the difference that's just occurred in the last 15 years or so is that we have been able to explore how cells react, and we've discovered that they are highly intelligent in that they can receive all kinds of information. They can measure them inside. They can make computations of a kind. Just as we've learned that certain animals can count in some ways, that bees can count up to a certain low numeracy. Our cells can compute. They can discriminate. They can collaborate, cooperate. They establish codependent relationships. They trade resources freely. They are altruistic. They can be mean. They can be extremely competitive, and they can often use that competition in a mutually advantageous way. In other words, the term is anthropomorphizing. I'm not trying to make cells into little tiny humans.
I understand.
I'm going the opposite way. What I want to get people to understand is I'm trying to cellularize humans. I'm trying to get people to understand that they're cellular beings, and that's really an important thing for them to learn. And the reason for that is because we're in the middle of a terrific revolution in biology that nobody knows. Well, only a few scientists are aware of. Everybody knows Kim Kardashian, and everybody knows Meghan and Harry, and they can tell you everything about their lives. But in the background, this magnificent explosion of scientific knowledge is occurring. And it's going to dramatically change your life. And your life, if you're middle-aged and above, it's going to very substantially change the lives of your children and grandchildren.
Would you give me an example? Because I understand what you're saying. I also have talked to people who really focus on botany and talk about, how trees talk to each other and all this. But could you give me an example, maybe with a toxin or a virus, how our cells do what they do?
Well, I'll give you a good example. There's antibiotic resistance, which is a problem for us. It's a problem for cells. Cells are problem solving and intelligent. So the cells are very social. They live very active social lives. They're not on Tinder and they don't do Match, but they're very extremely social. In fact, the free living cell, the cells that are just the loners by themselves, they exist, certainly. But that's by no means the majority. The majority form associations called biofilms. And the best way for anyone listening to think about it is it's a complex city. It has nutrient channels. It has basically highways. It's extremely complicated in its architecture, three-dimensional architecture. And this is the form of life that almost all cells prefer. Germ cells prefer, bacteria. And the reason for that is they have energy efficiencies, they can share information, and they can share nutrients. So what happens in the case of antibiotic resistance? Well, it turns out that not every cell has the proper, it's a thing called a plasmid. It's a type of viral particle inside of a cell, a viral remnant. And it contains the genetic coding, the tool, the cellular tool that the cell needs to resist antibiotics. And how smart are cells? They will partner. They'll communicate amongst themselves, and those that are deficient will get a donation by a special attachment, a tiny little filament called a pilus, and it will attach. It's a little nanotube. It'll attach, and they'll transfer over the correct genetic material. They'll donate it to a receptor cell that now transforms into an antibiotic-resistant cell. And in turn, some nutrients flow the other way. So there's an exchange of resources. And this is part of the adaptive mechanism of cells. In this case, it's not to our benefit, but it gives you an excellent illustration of how we need to review what we understood about ourselves and the cellular world. So this new transformation that I'm talking about, I call it the seventh revolution. It's the era of the cell. And it's the seventh because, at least in medicine, there were 6 earlier ones. There was antisepsis, and then there's vaccination, anesthesia, which changed the world, Pasteur's germ theory. There's medical imaging that started with Röntgen and X-rays, but your MRI and the ultrasound that you have, that's all derivative of this transformative moment. And then there are effective medications like antibiotics that have saved millions of lives. We're in the seventh, and this one arguably is going to be the best one ever, because it not only will improve our health and well-being, it will dramatically re-engineer the way we create products, create new efficiencies, much more, a much fuller life for all of us at all levels, but most particularly health.
Hi, everyone. You may have noticed that Zestful Aging Podcast does not run a lot of ads. That's because I'm just not willing to endorse products that I don't have total confidence in and that I don't use myself. So it really means something when I tell you that after I interviewed Dr. Bill Rawls on cellular health, read his books, and learned about his high standards for quality control, I was sold. I placed an order for Vital Plant supplements immediately. I encourage you to check out both of my interviews with Dr. Bill Rawls and hop on over to vitalplan.com. If you enter Zestful15, they will give you a 15% off of your first order. I'm really excited for you to try these products. I think you'll be very impressed. Now, back to the show. Give an example about how this is going to kind of enter the sort of the regular person's life. How are they going to be helped by our understanding of how important cells are?
Great question. The first thing, just as a bit of preliminary background, just very briefly, we now understand ourselves very differently than we did even 2 decades ago. You look in the mirror, you see a single person. I look in the mirror, I say, George Clooney, eat your heart out. You're such a handsome devil. Truly, George Clooney has nothing to fear from me. Anyway, you see yourself as a singular being. That's an illusion. Your trillions and trillions of cells work together so seamlessly that it allows you to believe, to think as a single being. But what you are is this enormous aggregation of cellular life. And importantly, it's a combination of both your personal body cells, your liver cells, your kidney cells, and so on, blood cells, but a cohabiting, a companion microbiome, that's bacteria and fungi and viruses, but the bacteria is the one we know about the most. And these aren't just hangers-on. We used to think that all of these were just plain old pathogens, harmful to us. They are our foes. That's what I was taught in medical school. Or they're hangers-on. Another word, commensals. Just means they're hanging around and doing their thing and they don't mean much to us either way. That's completely wrong. Now we know that these are absolutely vital partners in our health and well-being. And at every level, they assist in producing our gut microbiome, for example, assists in producing very vital substrates, metabolites, short-chain fatty acids, free radicals, polyphenols, amino acids. They assist us in absorbing and actually creating certain types of vitamins. Vitamin K is a very good example, which is necessary for effective clotting. We are extremely dependent on our microbiome. We can't survive without them, and they can't exist as they prefer without us. So we understand now that we're a partnership. So where will better health come from? By cultivating that partnership, by learning the secrets of how we can boost that partnership, and where there's an enormous amount of research that's happening now, that's going to better inform us about how to go doing it. But here's the very big difference between only a few years ago and this moment is Now we know where to look, and we know why to look. And we didn't know that. And that crucial difference, knowing that our cells are smart, knowing that they problem solve, knowing that we can leverage that problem solving for our advantage, knowing that we can skillfully help our partnering microbes to improve our health and well-being, that's the vital difference between then and now.
That's fascinating. You're really going from the ground up here. And it makes me think, and correct me if I'm wrong, is that even with food and diet, you want to feed those good microbes. You want, and in psychiatry, you know, there's a lot of talk now about your mood is directly related to what's happening in the second brain.
Yes, absolutely. In fact, your listeners will be interested to know that there's a whole new category of, it's not a pharmaceutical, it's bioactive compounds. They're called psychobiotics. And what we're talking about is skillfully manipulating the gut microbiome to help with depression. Well, why? Let me explain why that works. I was talking about the gut microbiome helps produce certain metabolites. One of them is serotonin. Serotonin is a critical neurotransmitter that helps stabilize our mood. It helps, in fact, it's very important for governing mood. And as a psychoanalyst, you know that it's a target of many kinds of drug therapies for depression. So we're critically dependent on our gut microbiome for serotonin. 90% of it is a product of their metabolic substrates. So if we can learn how to manipulate that for our benefit, then we will enhance our well-being. And we believe there are pathways that are open to us now that weren't before. And there's pretty good basic research you were just mentioning that this is bearing fruit already. And let me just say, we're just at the very first inkling about how to do it. The exciting thing is we're off at the very start of an explosive channel. And so I think we have the right to extrapolate that from this kernel of new knowledge, very fresh, dramatically different from what it was, gives us an abundant future. It's the best is yet to come.
It's so exciting, and I can hear the excitement in your voice. And I'm thinking about our audience, and they might be saying, listen, I'm suffering from some depression. I'm suffering from some anxiety. How can I befriend my microbiome to put me in the best position possible?
A terrific question. Let me answer that again with a little bit of evolution, just a tiny bit. No math is involved. So,
Good.
Humans like ourselves have existed for at least 200,000 years and certainly no more than 300,000 years. So that's when we diverged from our prior ancestors. And of course, we diverged from chimpanzees about 5 million years ago. But in any case, talking about just us as Homo sapiens, as humans that are modern like ourselves, 200,000 to 300,000 years of continuous adaptation, evolutionary adaptation. And here's the principle that we have learned that we didn't know just a few years ago. All evolution is coevolution, meaning all evolution of our body cells is a coevolutionary experience with a cohabiting, companion, partnering microbiome. And so is our development. So our metabolic processes, our physiology, and our mental health are all a product of 200,000+ years of continuous adaptation with our partners. Here's the problem. Now that we live in urban environments and we're no longer hunter-gatherers, we don't live on farms, we don't roll in the grass, we don't get our hands dirty, we don't sleep 5 people side by side. And that's our evolutionary history. Grubbing on the ground, struggling, calorie restriction, calorie insecure, real calorie insecurity. That's our entire evolutionary history. How do we react now to this superabundance of calories? All of the refined sugars that we have, the new refined foods, all of these new additives. Many of them are blessings for our taste buds, but they're not our evolutionary pathway, and it carries a price. And so the scientists have come up with a term called missing microbes, and most of that has been centered on discussing the modern real surge of allergy and asthma, especially among children. And they think that this separation from our past, separation from our microbial companions, we're not acquiring the exactly correct microbes in the right proportions. And so that leads to a heightened set of immune responses that plays out as asthma and allergy. Well,
I was wondering about that because it's so interesting. Even now, you get a wedding invitation. It says, "Do you have sensitivity to any this?" And in my lifetime, that's a new thing.
Absolutely.
Everybody is like, oh, you can't come near this kid because they have a peanut allergy. That one has, yeah.
Yeah, no, you're absolutely right. Partly it is awareness. Anyway, I think we can both agree on that. But the other part, we haven't had an explanation, and we're developing that explanation through this concept of it's called the hygiene hypothesis. It just means we're missing exposure to vital companions. So this plays out in our gut. What's one of the major differences between the then of our evolutionary history and now? Most of our diet was roughage plant sources, high volumes of plant sources. If you look at undeveloped areas, they still consume much more plant fiber than we do. We're critically fiber deficient. And that fiber is an essential nutrient for the good gut microbes. Not every single one of our gut microbes improves our sense of balance, our health balance. They're not being directly harmful, but they're not our best players. So one of the things that we can do to improve our health at any age, but especially healthful aging, is to concentrate on improving the quality and quantity of fiber in our diet. And anyone can go on the web and look up what prebiotic, and probiotic means. These prebiotics are certain types of fibers that our gut microbiome uses for its betterment, for its own sense of balance. And probiotic means adding living bacteria, adding those bacteria that we think we've been missing and boosting their supply on a daily basis. That's a probiotic. And there's an excellent literature that both prebiotic, probiotic combinations, supplements, are one additional way to boost that balance, improve your immune resilience, and help straighten out your metabolic profile to cut insulin hypersensitivity, to improve glucose regulation, to fight metabolic syndrome, to help fight obesity. A lot of experimentation still needs to be done. A lot of confirmatory research still needs to be done. But very, very promising data is there. And these are things that listeners can do to start thinking about how to improve their personal balance, their gut balance, which they may feel ends up with lower levels of systemic inflammation. And I'll speak for myself. Having followed this advice that I'm just mentioning, I used to wake up with a fair amount of stiffness in the morning, and I just don't have that anymore. Now, that's anecdotal, and I would never accredit that in a scientific paper, but I'm speaking as a friend, as on a chat. And you can't help but mention your own living experiences and share them.
Mm-hmm. So befriending your microbiome. And now let's take this to the macro level, because this is the jump that I think makes your book so unique, and you can correct me. But you're talking also about how we're connected to the planet and the cosmos.
Yeah, I know it seems a stretch. When I started first thinking of these ideas, I was resistant. It seemed unlikely, but the connections are really, in one set of circumstances, they're absolute. It's not in any way theoretical. And the cosmos part is somewhat theoretical. Let me explain both. I mentioned before that you're a cellular being. You are tens of trillions of cells, both your own cells and your companion microbiome. Each of them is intelligent. You are interacting with them through communication and connections every day. Your body's a vast interconnectome. Your cells are affecting how you think, whether you feel it or not. You're affecting them in some tiny level, and you're affecting their intelligence and their adaptive ability. You're shedding these cells by the billions every day. You can't see it. You're surrounded by a microbial cloud. Where you're sitting, Nicole, is billions of microbes circulating around you. And some of them are coming and attaching and then leaving. And then you're shedding your skin cells and you're shedding your skin microbiome, which is attached to your gut microbiome, which is attached to your liver microbiome.
Oh my goodness.
It's all these connections are real. And what's the proof? Bloodhounds can track you unerringly. You leave a personal signature everywhere you go, whether you want to or not. There's a thing called the principle of Locard. Locard was a Frenchman who's Sherlock Holmes of his era. And he was the first person to come up with the idea that every person that commits a crime leaves something at the crime scene and takes something away from the crime scene. It could be a bit of paint. It could be a hair fiber. It could be a piece of carpet from a rug. And every modern show that you see, Forensic Files and all these shows, are dependent on this principle of Locard. Well, as it happens, this principle of Locard is exactly what cells are for you. Everywhere you go, you are leaving your signature, and it enters the permanent fabric of the planet and circulates.
I just need a minute to digest that. No pun intended. That is so amazing and awesome. There's something that's so how shall I say it? There's something so beautiful about it.
Exactly. Thank you. I completely agree. It's a ferociously odd idea at first thought. And then you realize, well, the evidence has been before us. We just didn't understand why. How does a bloodhound distinguish between two twins? And can do so months apart. And how can a bloodhound track you over 100 miles even if you cross a river? It's because of this signature that you're leaving that we just didn't understand it before. Now that we do, so what does this mean? It means that your intelligence is imprinting on the cells that you're discarding, and your intelligence is becoming part of a planetary intelligence. It's not sci-fi stuff. It's a linkage of intelligent problem-solving interactions to environmental stresses. And that's how the planet is connected at every ecological level from one to the other. And there is no place that is not so occupied. You could go down many, many miles below the Earth and recover abundant microbes. You can come up to the stratosphere. You can go up 60 miles up above the Earth and you're going to find microbes circulating. That's the planet we actually live on, not the one that we thought we live on. So you leave a permanent signature on this planet just by your existence. I think that's a
legacy that we hadn't included in. When I talk about legacy, it's not something that I've
I know, but you are doing it voluntarily and involuntarily. So what's the proper legacy for you to leave? Well, I can offer that. Cells can partner together in their tens of trillions because they follow a certain set of rules. These are not imposed by any outside force. This is not a religion. This is what cells do. Cells collaborate, cooperate. They accept codependent relationships. They trade resources. and they compete, but generally they compete very respectfully with one another. Why do I say that? Because every cell has an individual identity, self-identity. And the entire story of cellular life is going along to get along to protect that self-identity. Cells want to survive. They want to protect themselves. How do they do it best? Through each of those things, collaboration, cooperation. What have cells learned that has eluded us, superior humans? You serve yourself best by serving others.
Oh my
Through
goodness.
those reciprocations. What's the purpose? What is your purpose? What is your living purpose? Cells teach us that. It may sound
You're gonna make me cry.
No,
As a psychotherapist of 30 years with a specialty in food and eating issues, I know that holidays can be a real challenge when it comes to eating and food. Food and family visits are often a very tricky combination. So if you'd like to learn how to have a more peaceful relationship with food, both during the holidays and the rest of the year, check out my web course, The Wisdom of Mindful Eating. This course is super practical and user-friendly, and it has the power to change your life. You'll find the course on the zestfulaging.com website. Now back to the show. Let me ask you this question while we're on this amazing piece of the puzzle here. How has learning about this, you were a medical doctor for a long time, then you discovered this evolutionary biology, you were all in. How has learning about cells and their behavior changed your behavior in your life?
Well, I just said you serve yourself best by serving others. And I think that has made me a nicer person, a more generous spirit. I want that to be my signature.
Mm-hmm.
So how do we go to the cosmos? So, I mean, it sounds whifty, it sounds like I'm making stuff up. Here's another part of cellular life that's vitally important. Of course, cells are dependent on energy sources. They use energetic processes to sustain themselves. Some of those follow classical thermodynamics, but as we're learning, many of the processes that cells use are quantum related, quantum mechanics. And quantum mechanics is a complicated issue, but our senses, our vision, hearing, and our sense of smell, olfaction, are all dependent on certain kinds of specific quantum processes, quantum electron tunneling, certain types of non-locality. What this means, though, there's an implication of quantum processes. They allow entanglements. So what do I mean by that? Entanglements mean, in quantum physics terms, in the simplest way, one atom in one place can be simultaneously connected without there being any fiber connection or anything like that. They are related, and their existence is entwined, it's entangled. The spin of one electron relates to the spin of the other. You change one, the other changes instantly over any distance. The experiments have been done over smaller distances, up to kilometers, a mile or so. But in theory, it could go out, it does go out everywhere. And one of the principles of quantum mechanics is that if it works in one specific subsystem, then it's operative in all other systems. So there's a really very surprising implication. Our intelligence somehow connects out there. It may not be the intelligence that we want. It may not be the afterlife that people yearn for. That's not what we're talking about. We're talking about science here. It means that there are hidden connections, and you're part of them, perhaps permanently. And I find that very helpful. I like that idea. I like that idea because it's good science. And there are many scientists who believe that in a thing called pan-consciousness, Nicole, and you're familiar with it, I'm sure. It means that, and brilliant individuals, philosophers, metaphysicians, and scientists have talked about this for a very long time, that it's a consciousness-connected universe, that the only real thing in the universe is consciousness. The energies and the atoms, they're derivative of that consciousness. And we don't have time to go into that. It's a very interesting concept. But one thing that I think you can take is you are permanently here on the planet, whether you want to be or not. And you are probably almost certainly permanently connected to the cosmos.
Mm-hmm. Do you have a hard time talking to your colleagues that don't do evolutionary biology? Is it hard for them to join this way of thinking?
That's a terrific question. No one's ever asked me that question before. Actually, the answers suddenly occurred to me slightly disturbing. I don't talk to anybody else. No, people are not, my circle of friends are the most wonderful people I know, but they don't have a specific interest in evolution. I wouldn't bring it up because it's much more complicated than they're interested in. We have other interests that we share and we talk about avidly. In my professional life as an academic, with papers and books and emails all day long, these are my colleagues. This is my hood, as it were. And so I don't really talk to other biologists. I used to be with physicians. I can offer this. I was a practicing physician for 35 years. I only developed an interest in biology out of nowhere towards the very end, before I switched fields to become an evolutionary biologist. Of course, brimming with enthusiasm about my ideas, I discussed that with my medical colleagues. And I'll be candid, they could not have been more disinterested or uninterested, I guess would be correct. It just didn't resonate with them. They didn't care. So I'm hoping that I can communicate. As part of this vast connectome that we're part of, I'm hoping that I can communicate to other non-scientists that care about these topics as much as I do, and open up to them a whole new world of possibilities that they've never thought about before.
And you're working on a docu-series to help lay people understand this. Am I right?
It is in development. Progress is glacial, but I'm hopeful and excited about the possibility.
I imagine that making this simple enough for people without a biology background is a challenge in itself.
It is. I've found that among the people that are going to be interested enough to listen to this program, for example, and continue it, through the first few minutes, and those people that'll read my book, and those people that will tune into a docuseries in which it's billed as being about a certain topic, the microbiome or so on. But these are all very intelligent people. They're all completely capable of understanding these arguments, as long as I don't use technical terms. Everybody gets it. I think the only idea that I think is daunting is trying to make people understand the implications of quantum physics. No one has to understand. I don't understand quantum physics. In fact, almost no one does. I mean that. Actually, almost no one. I'm not sure. Someone, I can't remember who it was, it's not Feynman, but somebody brilliant said, anybody who thinks he understands quantum physics doesn't. It's a very set of tough things, the concept of non-locality, where an electron could be in two places at once, separated by 1 billion miles. It's almost unbelievable, but it is actual. That's confirmed science. Talking as I am about a connectedness of your massive collection of cells with their unbelievable numbers of atoms being connected elsewhere in space and time isn't far-fetched. There are other scientists that are smarter than I that believe that too, and frame it in a slightly different argument. I'm the first one to try to put it in discretely cellular terms. In most discussion of pan-consciousness is talking about human-type consciousness distributed around the world, the universe. No, that's not what I'm saying. It may not be your eternal life that you're hoping for, but it is evidence of your having been there. You've left an imprint out there. So I don't know if we have time, but I'll mention one other absolutely certain, absolutely scientific cosmic imprint. So NASA has been sending spacecrafts off Earth since the 60s, for sure. And they really worked hard. They tried to prevent what they thought was a very undesirable thing, which was sending microbes off into space. They cleaned their space capsules assiduously. They had a thing called clean rooms. And they worked hard. They tested those surfaces. They cultured them. They did the technology of the day. And they said, they're clean. They're ready to go. There's only one problem. Future scientific developments uncovered that those tests were wildly inaccurate, uncovering fewer than 10% of the actual microbial life. So we sent those spacecraft out into space, as we continue to do, and they're loaded with microbes. So now 2 of them, Voyager 1 and 2, the outer skirts of our solar system is called the heliosphere. That's where the sun's influence, gravitational influence, basic substantial amount of light breaks down. It's gradual, of course. Voyager 1 and 2 are now transiting out of the solar system. What have we done? We have inadvertently become, it's called panspermia. It was a theory that life came to Earth because it had been dropped here from an asteroid, a comet impact, or something like that. And that seeded life. Think of Earth was a fertile dirt, and the right molecules, living forms came here. Maybe the first protocell, the first very, very primitive cell. And that's how life began. There's no one to say that's wrong. But what have we done? We've become an agent of panspermia. We've sent these microbes off. So is that a good or a bad thing? Well, I'll put it this way. If there is life elsewhere in the universe, we become an invasive species. We've left a permanent imprint on the universe. We are consequential players in the universe. Now, if there's no life anyplace else, and that's also possible, well, it's not really harmful, but it's certainly consequential. In either case, humans have become, through their microbial proxies, cosmic players. And now we have both planetary stewardship, because we're part of this vital connectome on the entire planet. We have a duty to be decent planetary stewards because of our intellectual gifts, our engineering prowess. We now have, maybe among the first to assert this, a cosmic stewardship. If
a responsibility.
If you're sending life off and so people say, well, they're just microbes. How long can they last? That's the interesting thing about microbes. There are certain types of microbes called extremophiles. What this means is they can survive anything. So humans are very fragile. We're not meant to go into space. All the stuff that you're hearing about how we're going to go here and there, it's great for fundraising. It's terrific to get a government grant, but it's not happening. We are not, without a lot of extra engineering that we have no idea how to do yet, we are not fit for long-term spaceflight. The high energy, so all the space travel that we've done to date has been local. It's taken the local line, even to the moon. It's still within the gravitational pull of the Earth. So that means that the impacts, the cosmic impacts, are very different from deep space. Deep space is a totally different thing. And we have no experience of what it's like to be out there, except we know it's entirely destructive for us. Our cells are not capable, our body cells are not capable of going there. But our microbes, they can go into spore states. They can last 10,000 years. They can endure radiation. They can endure temperatures from minus 200 Fahrenheit to plus 250 Fahrenheit. They already do that. Their metabolisms are, not all of them, some of them are very fragile, but others are extremophiles, and we can send them out and they can go anywhere and they'll survive. But here's the other good news. We're in the era of the cell. And what that means is some of these internal engineering characteristics of these very capable surviving cells, we're going to learn some of those secrets, and that's going to translate into healthful aging and better well-being and terrific new products that make our lives better. I'll give you an example how findings in one thing translate to another. We certainly know that certain animals can regenerate limbs. We just don't know how to do it for humans. We will learn it. We will learn the secrets of regeneration. Whether we'll regenerate whole legs or not, I don't know, but we're certainly going to regenerate organs.
Back to the octopus.
Yeah, competent organs to make up for deficiencies. One of the great things I'd like to let the listeners to know is what's the best way to measure human progress? It's not political systems. The best way to measure human progress over time is what I like to talk about, an even break. What do I mean by that? Your chance of an even break of a long and happy life is getting better and better. Back thousands of years ago, life was brutal and short. It is not true that somebody didn't live to 70. It's just really few. And maybe even someone lived to 80. I'm not talking biblical sensibilities. I'm talking about actual lifespans. Ben Franklin lived to 80, I think, or very close, if not, maybe more. My point is there always were survivors, but the percentage of the population was tiny. Back in London of the 1800s, 50% of the newborns died of disease, smallpox, typhus. So I'm talking about being even. In my own personal case, I wear glasses and contact lenses. And because of that, my life has been pretty much even. Without them, I'm disabled because my vision is really bad. But I've been granted this privilege of evenness. So what I mean is that going forward, we're going to be living now at the very beginning of decades in which, absent war or other kinds of self-generated human catastrophes, everyone around the world has a better and better chance of being even. What this means is that the centenarians of Okinawa and Japan, rather than being living exceptions, can become the model of what we might all generally expect as a life expectancy, but better yet, feeling well, not feeling as though every affliction of old age is besetting them. You know, most people think as they age, they say it's hell getting older, but better than the alternative. Well, how about if you got older and you felt well?
Yes.
And that's what we're going to. There'll be one other derivative, and it's a term I like called salutogenesis. Why will we start to feel better? Why will we live longer? Because the era of the cell will mean much better biosensors, much more sensitive ways of measuring metabolism and correcting it. And salutogenesis is a general term that's been developed to mean that the health of an individual will be evaluated explicitly based on them. It's not one size fit all anymore. It means, we all know someone that's overweight but perfectly healthy. We also know people that have had high blood pressure and they mysteriously do quite well. And we know people that have had type 1 diabetes and live to 80.
Yes.
So there are these exceptions. They don't have to be exceptions if we understand the cellular rules and we can leverage the engineering capacity of our cells. The cells are the most competent engineers on the planet, and our engineering capacities are derivative of their engineering capacities. And if we can leverage this partnership together and understand it as a partnership, then we'll all live much better lives. That's even true for viruses. We used to think that viruses are exclusively parasites, pathogens, bad news. Well, new discoveries have taught us something else. Most viruses are neither harmful nor helpful to us, but a lot of them are very helpful. Our virome, our viruses, the collection of all the viruses that are part of us is called the virome. The viruses in an ecology. They're co-partners. Some of them are deadly. There's no doubt about that. But more or less, the vast majority of the time, they're co-partners. How much better could we make our lives if we learned the skills of partnering with them for our betterment?
Mm-hmm. That's fascinating. It's absolutely a total paradigm shift. Bill, where can people learn more about your work and understand more about the cellular revolution?
I write about this extensively, explain it carefully. I think in nicely accessible terms. Bioverse is the name of the book.
Mm-hmm.
It's available on Amazon, Barnes & Noble, any commercial outlet that you look. I have a website, ourbioverse.com.
Okay.
And then for those of you who are really more scientifically intense, I run a really nice science feed at Twitter, at Bill Miller, MD. And no politics, no social discussions. It's just really interesting science tidbits that you can get on a daily basis.
It sounds great. My head is just spinning, and I have really enjoyed speaking with you today. Thank you so much for sharing.
Nicole, it's been my pleasure. Questions were great. It's a privilege.
Thank you so much for joining us on Zestful Aging. If you like the podcast, please share it with some of your friends. If you think decluttering could help you feel better and you could use a little assistance with that, check out the online course I've developed with professional organizer and designer Carrie Luderin. It's called Too Much Stuff. And Too Much Stuff is different from other courses or articles or guidance you may have used up. We give you clear steps to deal with the clutter and the tools to help you face the overwhelming feelings and the emotions that come up when we're going through our clutter. And a lot of those emotions are just feeling anxious or guilty or just basically flooded with a lot of different confusing feelings. The course is really practical. It's realistic. The lessons are short and punchy, and they're really manageable. We're not trying to set you up for some long exploratory, super in-depth, burdensome experience. We want something really helpful for you right now. We all need help with our anxiety. So being surrounded by more calm and less chaos can really help. So now's a good time to clear out the clutter so we can focus on what's really important in our lives. So find out more at zestfulaging.com. You'll see more about this under the web courses tab. If you have any questions, just shoot me an email at zestfulaging@gmail.com. Thanks so much. And stay tuned next week for another interview with a fascinating and inspiring guest.